I'm Mads Dustin. I'm an architect at Microsoft, and I'm also the lead designer of C#.
And I'm Dustin Campbell. I'm an architect on .NET tooling and also a member of the C# language design team and work a lot with this guy.
Yeah, so we have .NET coming out today, .NET 9, and that also means that we have C# 13.
C# 13.
Meeting the world today, and we're here to tell you a little about what's in this version of C#. We want to start by taking you on a very brief tour of how you can stay updated on what's going on with C#. Like everything else here, it's open source.
Yeah, so I've got a couple of things up here on my laptop that should show. So just a couple of ways that if you're new to the C# universe or you want to get involved or stay engaged, we have a few examples of ways to do that at kind of various levels of interest, right? This first thing, this is learn.microsoft.com. This is the what's new in C# 13. So if you want to just find out what's in the product for C# 13 and get documentation on these things and how they kind of play in, there's all of it is here. And this is kind of a great way to kind of just get an overview of the languages that have shipped, right?
That is true. However,
language features that have shipped.
Yeah, the features. Yeah. As we go, like the C# 14 cycle essentially starts now. Mm-hmm. And as we go, we tend to put language features out in preview. And we actually have one that we'll be showing today that's already going to be in preview.
Yes.
And we try to keep the what's new page updated even with preview documentation of preview features as well. So it is a good place to keep an eye on C# as it evolves over the year, if you want to.
Another spot you can look at, and this is on the on GitHub in the Roslyn repo, which is where the C# and Visual Basic compilers and IDE stacks, all the code lives and where they're in active development. And this is the language feature status page. It's in the docs folder, where you can see the nitty-gritty on like who's working on what and what we're looking at for C# 13, and then also kind of what's happening for next. And if you're interested in seeing branches merge, this is where to go, right? So it's kind of a
yeah. The working state is really everything that we currently have engineering activity on, like somebody's building. Yeah. As a C# language design team, we work on even more things that haven't yet kind of started being implemented. Mm-hmm. And so the place to go if you really want to engage with the C# design is that we have a separate repo, C# lang, for the language design itself of C#.
And this is, again, it's in the .NET Foundation on GitHub. And it is this is where notes from our language design meetings are posted. This is where proposals are posted. There's issues and discussions, and we're actually, this is also an active development, though it's not necessarily the code development, but it's where kind of the nitty-gritty of the language design itself happens. So if you want to get involved in some way or engage with that, provide feedback, discuss with the team or and other like-minded folks, then this is the place to go for that.
Yeah. And there is quite a lot of community contribution in this repo as well to the design of C#, as opposed to the implementation we saw before.
Absolutely.
But I guess we're here to look at code.
Yeah.
Let's talk about many of the things. Like there's a long list of features in C# 13, and by the quotation marks, I mean that some of them really feel like just bug fixes. Yeah. We're going to show some of the more interesting ones. But as you could see on that language status page and the what's new, there's plenty.
Yeah, there is plenty.
Yeah.
And in a way, I mean, we've been kind of looking at the features that did land in C# 13, and it feels very much like, in a way, almost not necessarily small features, but features that might feel smaller, but they are there to just make genuinely the consumption of code just better, easier, make sure you're doing the right things, and putting you on the right path, giving type authors and library authors the right tools they need to help you get on the right path as for consuming APIs.
Yeah.
So it's kind of, there is kind of like a theme to it, even though it kind of feels a little grab baggy, but I like this idea that
It's very light on new syntax, but there's a lot of semantics sort of behind familiar syntax, if you will. Starting with this one here,
Params. Yes, this has been in the language since C# 1.0.
Yeah, Params has been around forever, and it's always been about arrays, right?
Yeah.
So you can have a Params array, and that means that call up there on the first line, you all know this. It just packages all the arguments for that parameter into an array that gets created on the spot and passed on to the method.
Right. And almost immediately after this shipped, we're like, why couldn't we do, params IEnumerable? And then .NET 2 came out, C# 2 with generics, and they're like, well, why can't I do one with params IEnumerable of T?
Of T.
Yeah. That's been maybe the oldest ask remaining, in a lot of ways.
To be clear, and you may want to show this, the thing you pretty much have to do and have had to do in C# and C# 2 if you want to have a general API that takes all kinds of collections, but also is params, is you need two overloads. The general one that takes IEnumerable of T, and then an array one that is params, because only arrays can be params. You can kind of guess where we're going out there.
Right. But, this gives you the way to kind of have something that you can. If you've got a list in hand, you can pass that, and it will get make its way into the IEnumerable of T, and then in the other one you can pass a list of arguments, and they'll get into the params. And often, this is kind of implemented funny. You wouldn't normally do this. Usually you'd take the params one and you'd use that to call the IEnumerable one.
Yeah.
But it seems like every API that wants to expose params ends up doing something like this as well.
Yeah. And we've sort of had it on our list for well over a decade to do something about that. But then there's well, if we do params IEnumerable, and what about other people will immediately be like, okay, params, other things, right? And so we kind of left it alone. But last year, when we were releasing C# 12, a very consequential feature came out, which was collection expressions.
My favorite feature in years, right? So to be able to surround this with brackets and just say, this is now a collection that is not exactly opinionated on the type of that collection. Instead, it decides what the collection is going to be, what the type of the collection is, based on its surroundings, right? Essentially. So in this case, it would be, this is a way that you could also pass it in here and get a, and it looks like very similar to passing params, right? But it's really close with just these square brackets.
Yeah, but the big difference with collection expressions is that you can, and some of you might not have picked them up yet, please do, they're awesome.
They are fantastic.
Is that you can pass collection expressions to almost any collection type, right? There are standard ways that they will work. They will work like old-fashioned collection expressions, or collection initializers rather, if you don't do anything else. But you can also set things up in your API to tell it what to do to create your collection in a smart way. And the compiler special cases a lot of common types and so on. It's really smart. It can create, from the same syntactic expression, it can create all kinds of different collections. And it'll do a really good job at creating efficient implementations of interfaces and that kind of stuff.
Now in this case, overload resolution is going to make it so it calls the array still.
Yes.
But if I delete that, and I can delete that now because I've got that collection expression up there, it will produce, the compiler will generate a type that's very, very efficient that implements IEnumerable of T for you. So you don't have to go and say, I'm newing up a list or I'm newing up something else to pass in here, but instead it will new up something that implements IEnumerable of T so that it can be passed here successfully and efficiently.
And so that little extra step we took in C# 13 is, okay, now we have machinery to create all kinds of different collections from elements, from a list of elements. Couldn't we just do that with params as well? Couldn't we just allow params on all those collection types and have it do the same thing?
And it turns out we can. And so this, of course, is now legal in C# 13. We have params for all sorts of things. And basically, essentially the things that you create collection expressions. Because we know how to build that machinery now. So if I delete these brackets, it works just fine, and it's going to do essentially the same thing under the hood as if you passed in a collection expression.
Yeah.
It's beautiful.
You can pretty much think about it as params is just the compiler putting those square brackets around the elements that you're listing as arguments, right? So it's those two features are very closely connected.
Absolutely. Now, in this case, because IEnumerable, we're going to be allocating something on the hood, under the hood to do this. And there are cases where you don't want that, right? And so you might wonder what other things we could do with params. If I wanted to do something a little bit more efficient using some of the span-based types that we have, that's also allowed, right? So I could type, span in here, that works, or I could use its, read-only cousin to pass in, arguments that are, essentially could be from some heap allocated type. It could be from an array, or they could even just be allocated on the stack. This could point to memory on the stack so that you're not making any objects to pass something in that can then be for-eached over like this.
It's actually, and this is like probably the second longest request we've had for params is for the span types, because the compiler can choose to allocate that span on the stack, right? And when it does, no memory is wasted, and it's actually very similar to if you had all those parameters individually in your signature, they would also have gone on the stack. So this is a thing that sort of from a memory layout performance perspective mirrors multiple parameters the best.
And there's another piece of this that I think is really interesting, which is that, overload resolution would like to say that in this case, read-only span is a better overload because it would implement IEnumerable of T, but of course it doesn't. It can't. And so it's a ref struct. It can't do that, and IEnumerable is not suitable. But still, we end up picking the read-only span type here, and this is part of another feature of C# 13 that is kind of like, sort of, I would say, kind of one of those things is really under the hood. You won't see it, pop up, but it will help you do the right thing.
Yeah. So we essentially embarked on a new story arc, if you will, in C# for spans that is first-class spans. Like even though spans have been around now for a long time, a lot of people, they have weird restrictions and so on because they have to live on the stack and so on. So a lot of people don't use them directly, but we want to make it so that you can get a lot of benefit from them without having to understand too much of that machinery. And so, but the language itself has kind of kept them at arm's length for a bit. Like there are conversions from array to span to read-only span, but they're not in the language. They've been user-defined conversions on the span types and so on. And that means spans haven't felt fully integrated in the language. But we have started down, and there'll be more in C# 14, making spans first class. And the sort of down payment on that in C# 13 that you see here is that we make spans better than arrays and all the interfaces implemented by arrays in overload resolution.
Right. I mean, it is the more efficient way generally of doing that, and so it makes sense. Yeah. All right, so another thing about params collections is we said, we can do an IEnumerable, okay, we can do read-only span, but we can do lots of other types. And so there are also ways with collection expressions to, expose them to collection expressions in such a way that collection expressions knows how to build them. One of the types that's been kind of challenging, I think I even showed an analyzer on this years ago in a What's New on C# talk, but the idea that like a mutable array is one of those types that we use a lot, but we especially use a lot, but it can't be used with the old style collection initializer,
right? Where
I new up and put the curlies and add the elements, because under the hood, a collection initializer just calls add methods, but the add method on an immutable array doesn't mutate it. It just makes it do it just makes it do a immutable array. So it doesn't work. And so we made sure that when we added collection expressions that we could support types like these as well, and that means they're also supported with params because of a special attribute you can add to make your collections work with collection expressions and also with params.
So you really have a lot of freedom now in how you use params. Of course, you want things to still, you want overload resolution to still
work.
I'm
like
trying
you
to scroll up a bit there.
And this is one of these things where it's like, oh gosh, what's wrong? I have no idea, and even these sorts of overload resolution problems of like now we've got an ambiguity.
Of course, in this case, we we have params and 3 different overloads.
Oh,
and you
yeah.
probably wouldn't have
We
that.
could fix
So
it. We could fix it like this, right?
We could fix it by just saying, yeah, we probably want the
would you-
read-only span to be the params
Yeah.
one, because that's the most efficient of them.
Yeah, and so that makes the most sense, right? And so then, but then if I add this, if I was passing in a collection expression, which could be either an immutable array or an enumerable or a read-only span, we're right back in the same problem.
Yes, and this is a situation that you sometimes find yourself in if you are consuming, or especially if you're writing a library, you're maintaining a library and adding to it over the years, and you want to add new overloads. Like in this case, this might have been around for a while, but the read-only span overload is new, right? You want to add that for more efficiency for your users to pick that up when they compile. But now you've introduced ambiguities.
Yeah, and the language just didn't understand. The rules of the language were not enough for that particular fine-tuning use case you had. You were like, okay, maybe I've got some API that we've got a better way to do it in this, whatever the organization or application. And so you want it to work, and it doesn't work, and there's an ambiguity, and now you got to do other things like change the method names, stuff that like you're trying to fit into the rules, right?
Sometimes the language can't make rules that fit everyone, and you kind of want to be able to have some agency when you evolve your API to make it so that the user of the API just gets the right stuff and doesn't get presented with that, especially that we don't break their existing code maybe that didn't used to be ambiguous and now will, but also like that they get the right things. Even when those right things are different from what they were before you made the change.
So C# 13 brings something here for that API author, even if it's an internal or public API, to be able to come in and say, to do the fine tuning, to say the rules didn't get it right for me or didn't do what I expected, and I want to fine tune it. And so you can use this new overload resolution priority attribute. And what this does is it essentially says all the overloads here they have a priority of 0. And so if I want one to be picked above that, maybe if it's a better choice, then I'm going to give it a higher priority. And that actually fixes the issue here. Yeah. So now it does pick the read-only span, which is cool.
It is very cool.
Yeah.
And sometimes, of course, what you want is you don't want a particular overload to kind of step in front of the others. You want one to step behind the others.
Yeah, and so you can use negative numbers, meaning that you have 4 billion of these available to you as you build out your applications. Yeah. But using a negative int here, and now this actually goes below IEnumerable of an immutable array. And there's still no error, and but it's choosing a mutable array because now regular overload resolution is kicking in and saying at that top level and saying, well, okay, a mutable array is a better choice than IEnumerable because a mutable array implements IEnumerable. Yeah.
So the way, and of course, it's not just a matter of positive and negative, right? You can use different numbers, and their relative priority
use prime
kicks
numbers.
in.
You could do whatever.
Yeah, I would probably use squares.
Maybe,
Powers of 2 would run out quickly.
They would. They're just the 32. Though that's actually kind of a joke because I kind of feel like this should be used sparingly.
Yes.
Right? This is used for that fine-tuning sort of a situation where you just need to get something to get the rules to choose the right thing. You just need to subvert the rules slightly. If you find yourself actually using 32 of these, you might rethink things.
It would still be a smell, right? Usually you want your API to, by and large, work by the rules and not against the grain of the language.
Yeah.
It's mostly, but not necessarily only, but it's probably mostly situations where you are evolving an API and you want to keep existing code happy even while you are able to take bolder steps, like for better performance, like add a new overload and move the params to it, that kind of stuff.
Yeah. Now this doesn't, if I recall, this doesn't actually have situations where somebody could add an extension method and now subvert your type or something like that. It's only the overloads within this type, right?
Yes.
Yeah.
Yeah, exactly. The priorities are only used between members of the same type. And the way, essentially the way it works is it takes all the applicable members, it finds the highest priority among them, and only the ones that have that highest priority get to compete for being chosen as.
Yeah. So if the top one succeeds, then it wins, right? But if it doesn't apply, then it would fall down to the next priority and let them duke it out. Yeah, which is great.
And so you can still, even though you have a lower priority, you can still get picked sometimes if you're the only one that fits the call.
Yeah,
if you will.
Yeah, absolutely.
Okay. I think let's go and look at some other code.
Sure. And that's 3 features down in C# 13.
Yeah.
And we're coming over to this
very little
file.
syntax so
and
far.
Very little new syntax. Actually, no new syntax.
Yeah, not so far.
Yeah. Now here we are in this file, and it is. It takes a little bit to absorb, but we've got a type called myFile that's partial, and in here there's a partial method. Think back to like C# 2 to remember your partial methods. And down here is the implementation of that partial method. Now, partial methods have always been used for code generation scenarios.
Yeah.
Right? And so they are ways that you can say, here's a method that I want to provide an implementation to in a partial part. And they're used more now in the world of source generators. We've had them for a long time, but they're used in source generators as ways that you can, in your type, you can say, here's a hook that the source generator can fill in implementation for, or vice versa, where you want to provide implementation and the source generator is going to provide a hook. So it works very well for kind of both these kinds of scenarios. Yeah.
But up until now, the only member kind that could be partial was methods.
Right.
And we've finally just taken the step and added partial properties as well.
Right, so I can go ahead and add a partial keyword to the implementation side, and then I'm going to come back here.
Because now it's complaining that there's no definition.
There's no definition, so I'll go ahead and add my definition. I think I need a private set because we need the accessibility accessors to match. And why haven't we done this before? It
seems so straightforward. The reason there were dragons, but they were more like tiny lizards, but we kind of stayed away from it for a couple of years because of that. Because if you notice that get private set, that looks like the body of an abstract property, right?
Yeah.
But it also looks like the body of a concrete property that happens to be an auto property.
Yes.
And so we kind of had to make the choice to say that when you put just, the accessor keywords and semicolons, is that an auto property that's on the implementation, or is that a definition? We just said, okay, it has to be a definition. That's the only way this can work sensibly. And that means that you can't use that same auto property syntax to implement it. You have to do something manually.
So auto properties aren't supported?
Hold that thought.
Okay.
Hold that thought.
Okay.
But not in that exact auto property syntax that you're used to.
Yeah. So, okay, this is again, it's a great feature for source generators and any code generation scenario, and now it supports properties.
Yeah. And honestly, we already get requests for supporting partial other member kinds now. So let's see, as the scenarios kind of warrant the work, it might be very little work. We'll probably keep looking at that, just generalize there. But for now, you got methods and properties now.
Yeah, that's fantastic. And that brings us to kind of another feature that we have here. We have, in here we're locking some data, and we're using this classic lock keyword that's been, again, something that's been in C# since C# 1.0. Not new syntax, again. Something that's been there for a very, very long time, where in C# 1 and .NET 1, we decided that from the design was that every object could be something that could be locked on, right? So any object could be used with the monitor classes and in .NET, and so that pattern is the one on lock. But since then, we have had no limits on putting new locks into .NET. There are so many locks to choose from.
Yeah.
And for various situations.
In hindsight, maybe it wasn't the greatest idea to enshrine the first idea we had about locking into the language itself and kind of hard-code it in, because it kind of almost created an adoption blocker for the other.
Oh, yes.
They're at a comparative disadvantage just because this very early first one is embraced. And there's nothing wrong with it per se, but we can do better. And
Yeah, and I would say that now we have a new idea for a lock.
Yes.
And that's what this feature is about. We've got a new lock that's in .NET 9.
And it's not called Semaphore Slim or anything like that.
No, nothing like that. No. It's called lock.
That's how confident we are in this.
Yeah, but I changed that map lock field from object to lock, the new system threading lock, and it works with the lock keyword, and that's kind of a new feature here. That it's sort of just we allow the lock statement to be used with this new lock because we feel that this is kind of very similar, used in similar scenarios.
Yeah.
But it is lighter weight than the old one. The old one has extra baggage with monitor and features there that felt like, well, okay.
Yeah.
Something slimmer and lighter weight to be used as kind of the workhorse lock for these scenarios of just protecting data.
And to be clear, this would have worked even if we had done nothing in C#, because lock is an object. So, so locking on it by rights should just do the same monitor thing. But what we said here is that's wrong. Let's embrace this new lock type in the language. And so when the lock statement is used on an object of the lock type, like the static type lock, like the compiler can see this is the lock, it will generate the more efficient code to use it actually as intended, to use that lock type as intended.
Well, does that mean that then if I say new up a lock and turn it into an object, that can still use monitor?
That will still use monitor, which is like the risk of doing something like this. And so what we did, you can see the green squiggle there, is that don't do that, please.
Yeah.
If you have a lock object, don't upcast it and forget that it's a lock, because then if you use the result of that in a subsequent lock statement, it won't do the same kind of locking. It could get very dangerous and silly. So that we put a little guardrails on it there so that people don't mix locks and non-locks.
Yeah, because things might not lock like you think they should.
Yeah.
Things might have different semantics and do things in a weird way. And of course, the C# compiler has, once it's become an object and it's passed through, we have no way of knowing that it's not an object statically.
Yeah, unless we build a runtime check into lock, and now it starts getting inefficient and so on. So we didn't do that, but we put these guardrails in.
Right.
And also to be clear, this is not that we've sort of generalized the lock statement to be pluggable in a way, or to have, it's not that you can write your own types that plug in and have their own behavior in the lock statement.
Yeah, there's no lock pattern today, right? So this is not that. Again, it's a situation where that's actually a bigger problem if we ever wanted to do that. And so, but just for this type, because we feel that it is that important, that we want to do something different.
And if that other thing becomes a scenario that people are clamoring for, and then we could go there. We've sort of broken the seal on the lock statement now, but for now, we just want to embrace this really good type from the core libraries.
Yeah, that's fantastic. All right, let's talk about one of our features that's maybe not quite there, but it's very, very ready. I've been using it a lot.
Yes.
It is a feature that right now in .NET 9, it is only in preview. And so a language version preview. I don't mean .NET SDK preview. I mean, you can go into your project file, you can use .NET 9 GA, the general release, and you can specify language version preview to get access to this feature.
And we'll come back to why it's in preview and not part of C# 13 proper.
Absolutely.
But let's have a look at it.
Let's show that feature. That feature is something that we've shown a number of times, often with squiggles, but it really is here now, and it's the field keyword. So the ability to, within an auto property, to access the backing field, right? Something that, with an auto property, there's always been this big cliff. You have to, if you want to do various things, like in your setter, you just want to say trim that value that's coming into the string, before it gets set to the
or just lock on something before you do the mutation, as in this case.
Yeah, and that results in a huge cliff where you've now got to, well, if I want to do those things, I now need to go declare a field. I can't use an auto property anymore.
And I must specify both accessors, even though I only wanted to fiddle with one of them.
Absolutely.
So we're taking that cliff away. The field keyword is something you can use to say, in accessors and property accessors, to say, well, I am an auto property. I do have a generated backing field, and field is how I access it.
Yeah, no, this
However, I can still write an accessor manually if I want to.
If you want to.
Yeah.
This one actually does right now because it sets a field that's different from this, which is now the backing field.
Yes.
And so we're actually getting a warning here that we should be using field because the other accessor does. So that helps me not make a mistake and make sure that I'm using this. The backing field keyword as well, the field keyword, which is awesome. And so now that map field isn't needed up there.
You can see it's grayed out up there.
Yeah.
We're not referencing it anymore. So we just get a backing field of the same type as the property generated for us. Now, it may be a little excessive that we're actually locking on get.
Oh yeah.
So if we implement the get accessor as just return field.
Yeah, if we took out that lock, if we wanted to take out that lock, we could do so just like this because it's an auto property.
Yeah.
I used to think that auto properties had to have like a get and a set and semicolons, no bodies. And really and I thought that's what made it an auto property, at least when I looked at it. But really what makes it an auto property is whether you you had to like have a backing field or whether one was generated for you.
Yeah.
And so now auto properties come in this like large variation of syntax that you can use to really, kind of lots of ways that you can use to make your property experience much nicer and be more expressive.
And just to circle back to the
preview flag.
Well, we'll get there as well. But the partial thing from before. Now we are actually writing the implementation as an auto property.
Yeah. So that.
But because it's an auto property where at least one of the accessors has a body.
Yeah.
It doesn't conflict with the definition. The definition and implementation we can tell those apart.
Yes, and because it acts as the field keyword only, it is an auto property, which is exciting.
So that is pretty cool. But yeah, we should talk about why we didn't just ship it.
Why didn't we ship it, and why it's in preview right now. And the reason it's in preview is because this is a breaking change. In fact, we've talked with customers who have said they've gone through their code bases and said, I have a lot of fields called field, right? Maybe they're writing database schemas and they have an object hierarchy and they're talking about fields in their databases. Or maybe this is like, it's an academic thing and it's like, oh, well, I have a person that has a field of study
or it's a force field in physics.
Or it's in Star Wars, whatever.
Yeah, or agriculture. Like actually it turns out that many fields have fields.
Yes.
So it's a little bit of a breaking change to start saying, well, inside accessors, it's now a keyword.
Yeah, so
sometimes.
This now becomes a problem.
Yeah, if you had that field and you were referencing that. Yeah. And so we went through many alternative designs on this feature, and we're like, this is the best design. And this is the one that we're going to be happy that we landed on. Like 10 years from now, this is going to be right. But in order to do that, we have to do a little more of a breaking change to C# than we usually do. And so we sat down and said, okay, now's the time for us to come up with a breaking change approach for C# that we can use sparingly, probably not even once every release, though. Let's see. And so you can see that warning you get there. That's sort of like, we haven't really implemented that breaking change approach yet, but we're sort of on the way there.
Yeah, so right now it says you can refer to the existing member. You can use this dot field to access the field like you would normally if you had a parameter in a field that matched. Or, because this is a keyword, the standard way in C# to use a keyword as an identifier and refer to it is with an @
Yeah.
And so this is kind of what we think, this breaking change experience, which would do some of this kind of work for you and fix up the code that you have so that it doesn't break with the addition of this keyword.
But it's probably worth mentioning, if you say this.field, that works too.
Yeah.
And the reason that works is that field is only a keyword if it sort of occurs on its own, right?
Yeah.
So we made the sort of blast radius, if you will, of the breaking change as small as possible. It's only when you use it as a variable name, standalone, like as if it was a parameter, then it's a keyword.
Yeah. Amusingly, I'm getting that warning back again because now I'm using a field out there called field, but this one uses a backing field, and so now I'm getting, let's say, it's kind of funny. But yeah, this is where we want to go with field, and we hope that it will be, ready to go. And we want it to be there for C# 14.
And we would
ready to go.
And we would like you all to play with it a bit, and for us to understand, like, are we are we as right as we think we are about making this breaking change, and help us get the tooling experience and everything right around it, so that come C# 14, we can now deal with this breaking change with confidence, and everyone can embrace this new keyword.
All right.
Okay.
Well, we have one more thing to show.
Yeah.
And that's...
We finally get to why this all is a ref struct.
Yeah, I know, ref structs. The thing that, you write only if you're like David Fowler or Stephen Tobe or somebody like that, right? But here we have them. Here, I rarely write them.
Yeah.
But sometimes I do. And one of the things that's interesting about this particular ref struct is that it has a dispose method, but it doesn't implement iDisposable itself.
Yeah.
And the reason for that is that ref structs, if I want to actually want to implement iDisposable on this and pass it to something that took iDisposable, .NET would insist on that being boxed into an object because it's a struct, and then an object that implements iDisposable on the heap. But ref structs can't actually live on the heap. They can only live on the stack.
If you want to think about ref structs like your spans and read-only spans are ref structs. So those kind of limitations, they have to be on a stack. They apply to all ref structs, and therefore it would seem that implementing interfaces doesn't make sense because you can't convert to them anyway.
Yeah.
But it does in fact make sense, and we've now enabled it.
Yes.
And of course it finds here the dispose method needed to implement the interface.
Yeah.
But how do you use?
Yeah, how would we use it? And then we go back here and we see, okay, these methods actually take iDisposable, but they take it in as a constraint on T.
Yes.
And this is where you can now use a ref struct that implements an interface, and you could conceivably constrain it. So I can go right here and I can type my file, and all's good until it's not.
Yeah, but it's a start.
It's a good start.
Generic, kind of satisfying generic constraints is what interfaces are good for on ref structs. That's how you can use them. However, type parameters by default, they are not expected to be ref structs. You were never able to pass ref structs as type parameters, and so they make assumptions. They're like, if you have a constraint that says that you implement iDisposable, well then you can convert to it. And so we need to say something about the type parameter, that this type parameter actually does allow ref structs, and the syntax for that, if you want to kind of
it's very surprising.
It's very cryptic.
Allows ref struct.
Yeah. No.
So instead of a traditional constraint, it's more like a non-straint, right? It's this kind of like we call it an anti-constraint, which seems like a double negative, but it's really about this T does allow ref structs.
It allows extra things over the default.
And so that poses some limitations on the body of that method, right? Because right here is a conversion to iDisposable, but it can't be converted to iDisposable. Well, I can fix that. I could use T right here, and because T is constrained to iDisposable and allows a ref struct, I could still call dispose on it, but I can't actually convert it to an iDisposable because of that boxing issue. And you've said that you care about not doing that in this method by saying I allow ref structs.
Exactly.
Now, the other reason this works is because in .NET 9, we have added that particular, I guess, anti-constraint, non-straint, whatever, to a bunch of the core interfaces and delegate types, right? So this is added, on IEnumerable of T. So IEnumerable of T now implicitly allows.
You can see it there in the hover. It allows ref struct.
Right there. If I go over to
otherwise we couldn't pass T to it.
Yeah. If I go over to source.net, I can see right here in the source. Oh, that's the wrong one. Right here in the source, I can see it's right there.
Yeah.
And likewise, if I go and pick up something like action of T, where you've had these delegates for a long time, and now they've all been annotated to allow ref structs, so that if you have something that you need to pass into, some delegate somehow, you don't have to go now. You could do it with a ref struct, but you had to go define a new delegate with a parameter type of that ref struct because you couldn't pass it as T as a type parameter or as a type argument, and now we can. And so
it's the upshot of the story really is ref structs couldn't participate in any kind of abstraction. You couldn't, any kind of code that was abstracted over multiple different kinds, you couldn't write you can use ref structs for it, and now you can. They can implement interfaces, and they can be allowed into generics, and we do it all over the place. So they kind of been.
Yeah.
This is also kind of like a first-class thing that's happening with ref structs that we didn't have before.
Right, and so it's enabled a bunch of cool scenarios,
Yeah.
and I think there's going to be a lot more to come in future
Yeah.
.NETs. So.
And with that, we don't have any more to show you today.
Yeah.